Here we look at elimination reactions in haloalkanes, and elimination reaction will form an alkene according to the following equation. So if I've got, for example, CH3, CH, Br, CH3, this is 2 bromopropane, react that with NaOH, then sodium hydroxide now is going to act as a base, as we'll see in a sec, and we're going to remove a proton followed by the elimination of the Br. So what we're going to get then is we're going to form CH2, CH, CH3 will form propene. We will eliminate then the HBr. Will actually form water. Well, actually eliminate HBr, but the product will form actually water and sodium bromide. So that's my equation. So we're going to form an alkene. Let's have a look then at the mechanism for this reaction. Now, the hydroxide ion is going to act as a base. It will remove one potentially of 2 protons. What we've got then is the carbon here bonded to the Br. Now, what the hydroxide ion is going to do, it's going to remove a hydrogen from the carbon next door to the carbon with the Br. So it will potentially remove this hydrogen or this hydrogen. It will not, please remember, it will not remove this one. So what happens then is the mechanism, it will form a new OH bond. So it's acting as a base now, it's a hydrogen ion acceptor. And this here will form the water part of my products. So as this new oxygen hydrogen bond starts to form the water, again water, hydrogen must all have one bond, then we must break this carbon hydrogen bond. In the process, this is going to form the carbon-carbon double bond. As this carbon-carbon double bond starts to form, we break this carbon-bromine bond. And that gives us the first potentially of our products, and I'll draw the structure of this product up here. So what that will give us then, it will give us this R1, and then we've got a carbon with a hydrogen. We've now got a double bond. With a carbon, we've still got this hydrogen down here. Remember, we don't remove the carbon bonded to Br, and we've got this, still got this CH2 and the R2 group. So that's my first potential product. However, this hydroxide ion could remove the hydrogen in green, and following a very similar mechanism, you will get the following structure. I'll see if you can pause the video and see if you can come up with the structure. So what you'll get is the following. So what we've got now is, if we're pulling off the green hydrogen this time, then we've still got CH2 here. Still got a single bond, but now the double bond is here, and we've removed this hydrogen this time. So that there would be my product if the green hydrogen was removed. Now, if R1 and R2 are the same, then as I said, if R1 and R2 are the same, which it would be if it was 2 bromopropane, which is the example we've given here in this case both R1 and R2H, then you would just get propene in either case. If R1 and R2 are different, okay, you would get potentially two different products, two position isomers. So let's just examine that. So for example, if R1 was H and R2 was say CH3, then let's see what we get. So if that's the case, then here we get but1ene. If the blue hydrogen is removed, I'll just highlight this to show this is the blue hydrogen that we're removing. This is the green one. So if the blue hydrogen is being removed, we would get but1ene. And if the green hydrogen is removed, I'm hoping you can see that we would get but2ene, and potentially, remember this could be E or Z but2ene, so you could get an EZ isomer here. You could get E or Z but2ene, and this is but1ene. So that's the elimination. The key to remember here is that this sodium hydroxide must be in an ethanol solvent, not aqueous. So aqueous solvents would favour nucleophilic substitution. It's important to remember if we want elimination, elimination is favoured by an ethanol solvent. And that there is the elimination reaction of a haloalkane.